So, a few weeks ago, me and my girlfriend and her friend were discussing space and aliens in preparation for Project Hail Mary. Great movie, by the way, you should definitely go check it out. And the discussion ended up going something like this. You know, I don't really think there are aliens out there.
What?
Now, don't get me wrong, I definitely think it'd be cool to find out that there are aliens out there. I love aliens in fiction, Doctor Who, Star Wars, Mass Effect, but when faced with the arguments, I can't help but feel like maybe we are alone in the universe. Let me explain. To start things off, let's clarify what we mean by aliens. We're talking about complex life, the things that you see in sci fi,
You can eat like a bean and you're done.
things we can communicate with.
Someday, put it together.
What are you doing?
The stuff that cool nerds find cool, not single celled puddles that only nerds with microscopes find cool. Now, with that out of the way, here's the argument my girlfriend and her friend presented. The universe is so big and so old that surely there must be something out there. Now, this definitely feels pretty solid, even if there's a low probability of something happening. Given the universe is estimated to be 13.8 billion years old, that low probability begins to feel like it should be an absolute certainty. But maybe it isn't. Maybe it's a sufficiently low probability. One way to conceptualize this was proposed by an astronomer named Frank Drake in 1961. Enter the Drake equation. It might look intimidating, but it's really just a way to break down the problem into pieces. Some of the terms are pretty well known. We know that planets are extremely common thanks to missions like the Kepler Space Telescope, and we know that stars are likely to have many habitable zone planets. Other terms are a bit more uncertain, like how common is life, how often does intelligence evolve, and how long do civilizations survive. So, while the early terms probably aren't the bottleneck, depending on your inputs for the other ones, n could be millions or effectively zero. Why am I on the side of effectively zero? Well, it all has to do with the Fermi paradox. Originally put forth by physicist Enrico Fermi in 1950, simply put, if the universe is full of life, why don't we see any evidence of it? The Milky Way is 100 to 400 billion stars and about 13 billion years old by our best estimates. Which means that even with slow interstellar travel, a civilization could colonize a galaxy in 10 to 100 million years, which sounds like a lot, but in the grand scheme of billions and billions of years is effectively nothing. So, if intelligent life is even moderately common, the galaxy should be full of it. But, as far as we can tell, there's no alien probes,
I got mail.
there's no large, unnatural structures. So, why might this be? Well, there's a few proposed solutions to the paradox. One explanation is that we're just early. We might be the first or one of the first civilizations to form, so the universe might be quiet for now, but someday in the future, it might not be. While this is definitely possible, the question becomes, how likely is that? Well, the Milky Way is estimated to be 13 billion years old. In contrast, Earth is just 4.5 billion years old. That means our galaxy had almost triple the time that our planet had to produce a civilization. So, it doesn't really seem all that likely that we could be the first. Another possibility is that there are other civilizations out there, but we just can't detect them. Maybe they communicate in ways we don't.
Do you understand the words that are coming out of my mouth?
Maybe they're just too far away. And hey, maybe this is true. But there's still a problem with this. Even if civilizations don't try to communicate, they would still leak some kind of information through things like radio emissions, radar, atmospheric pollution from being industrialized. We can already detect exoplanet atmospheres, so in principle we should be able to detect different industrial chemicals, chlorofluorocarbons, or some kind of unnatural energy signatures that would indicate the use of technology. We've already observed millions of stars, monitored wide frequency ranges, and have groups like the SETI Institute becoming increasingly sophisticated in their methods. At some point, we might have to draw the line and say, maybe we've looked enough. Another possibility is the dark forest hypothesis, which essentially boils down to a bit of game theory. Think of the universe as a dark forest, and all the civilizations in it are hunters. If a hunter finds another hunter, the safest thing to do is eliminate them, in order to avoid the other hunter doing it first. In this case, making noise, being noticed, could get you killed. So, the reason we can't find other civilizations is because they're all hiding.
Oh my god, Peter!
Again, possible, but for this to work, all, or at least nearly all civilizations would need to independently reach the same conclusion, that silence is safest. But even among humans, people already disagree with this. Another explanation is the zoo hypothesis. It's essentially the prime directive from Star Trek.
Starfleet's mandate is to explore and observe, not to interfere.
Again, possible, but for this, it would require galaxy-wide agreement across independent civilizations of different species. It would also mean they'd have to go out of their way to prevent the leakage that we mentioned earlier, stuff like radio emissions, industrial activity, etc. Another explanation is that physics is just too big of a barrier. It might just be the case that interstellar travel isn't a problem to solve, and instead it's just an absolute limit that makes things too hard or too impractical to do. So, civilizations remain isolated.
Oh yeah? Watch this.
Watch what?
Again, possible, but automation changes the game completely. Von Neumann machines, named after John von Neumann, who formulated the concept, are a type of machine that can self-replicate.
This facility was designed, built, and is operated mechanically.
So robots building robots.
So, if you shot some out into the universe, it would begin expanding exponentially from planet to planet, landing, gathering resources so that it can reproduce itself, and then launching itself at a different planet. Even with interstellar travel at 1% the speed of light, you could colonize the galaxy in a relatively short amount of time, at a cosmic scale. So, maybe instead of trying to resolve the paradox, we give up the premise that the universe is full of life. Why might this be? Well, what is often referred to as the Great Filter is the idea that somewhere in the chain of events necessary to produce a galaxy-colonizing civilization, there exists a nearly impossible step. Common steps that are highlighted are going from inorganic matter to simple life to complex life to intelligent life, and intelligent life to interstellar travel and colonization. Starting with the first step, going from inorganic matter to simple life, or abiogenesis, this could be the filter. We've never been able to recreate it in a lab or observe it happening in nature. But it might not be. On a cosmic scale, life appeared on Earth relatively quickly, within a few 100 million years, and the chemicals required for it are relatively common in space, so given the right conditions, life might emerge easily. Moving on to the next step, we go from simple life to complex life, or endosymbiosis.
It's symbiotic.
Where eukaryotic cells are produced, which are capable of forming a multicellular organism. This could be the filter. We've also never been able to recreate it in a lab or observe it happening in nature, And as far as we can tell, endosymbiosis has only happened once in Earth's history. The next step, going from complex life to intelligent life, might also be the filter. Life might become common, even complex life, but maybe intelligence isn't. Evolution doesn't necessarily aim for intelligence. Natural selection just keeps doing what works. That's why many species thrive without intelligence, think bacteria or insects. And on Earth, only one species has evolved to a technological level. The final step, going from intelligent life to one that develops interstellar travel, might also be the filter. It's also a worrying look at our civilization's future, potentially. Many civilizations might just self-destruct before reaching a point in technology where interstellar travel and colonization becomes possible. Humans have been around for about 200,000 years, but only in the last century have we had technology capable of ending life on Earth, whether it's a slow death through climate change,
Did it, Patrick! We saved the city!
or a fast one through nuclear war.
War. War never changes.
And it might just be the case that maybe that's how most or all civilizations eventually end, and that's why the universe isn't full of aliens. So yeah, that's my whole reasoning behind why I don't think there are aliens. Still hope there are, though. Seems like the most likely way for me to get superpowers. All the mutation stuff from toxic waste doesn't actually seem like it's that realistic. But some alien magic, that seems doable, right?
Wow. I know, right?